Now let's see how to solve irreducible quadratic factors. That is when we have a factor in the denominator which is not linear. So here we have x squared. This is not linear, so we cannot solve it like we solved this one. There is a different method for that. So let's take a look at that. First we have x plus 2. This is linear, so we would just solve it like we were doing before. So we would get x plus 2. And for this one, for the quadratic one, we would write it like this: px plus c, and then just write the denominator x plus 4. For example, if you had more factors here, for example, if you had this, then you would just do the same thing, t plus e over x squared plus c. So this was just to get an idea, that's how we would do it. But for the purpose of this video, we would just solve our previous equation. So now the rest is same. We would take this value and we would multiply it on both sides. We'll multiply this here, then we get 3x plus 1. Then we will multiply by this factor, then this would get cancelled out, then we get x squared plus 4. Then here this would get cancelled out, then we get bx plus c, x plus 2. Now just open the brackets. Ax squared plus 4a plus bx squared, multiply this here, 2bx plus cx plus 2c. Now separate out the values on right hand side with different powers of x. So for x squared we have these which separate out its coefficients, and then for x we have these two, so we take out its coefficients. Then for the constants we have 4a and 2c. Now you have to compare the right side and the left side. For x squared we don't have any value on the right side, so we would just write 0. So we get 0 is equal to a plus b. This is our equation 1, equation a for coefficient of x squared. Now we would see a coefficient of x, we get 3 is equal to 2b. So you have to write x here because these were the coefficients of x. We get 2b and c. This would be our equation p. And now we get the constant, which is 1 is equal to 4a plus 2c. Previously we did them by the crossing method. Now we would do them by substitution. So we can get the value of either a or b here from this one. So we can rewrite this equation as b is equal to minus a. Now we would substitute this value into this equation. So we can write this as x is equal to 2, and now we write the value of b. So we get minus a plus c. So you get minus 2a plus c. Now separate out the c. So for a you get 2a is equal to c. C is equal to 3 plus 2a. Now you can plug this value into this equation. So we will do that now. we will write 4a plus 2, and instead of this c we will replace it by this equation. We write, now just open the bracket and solve for this. So we will get 6 plus 4a. We take the 6 here, we get minus 5 is equal to 8a, and the value of our a would be minus 5 over 8. So we have the value of our first variable. Now we can plug this in any of the equations. So we will plug it in this one because it's the most easiest. Just replace a with minus 5 over 8 plus p, and now we can just get the value of our p. It would be 5 over 8. Now we need to get the value of c. And we can just use this equation for that. We will write 1 plus 4. Sorry, 1. We have 1 is equal to 4, and instead of this a, we would just place the value of a. And here we would just write 2c. Now let's solve this. We get minus 20 over 8 plus 2c. Take it to the other side. X plus 20 over 8 is equal to 2c. And if you solve this further, you get 8 plus 20 over 8 is equal to 2c. 28 over 8 28 over 16 then you can just simplify this and you would get 7 over 4. So the value of our c would be 7 over 4. Now we will just take these values and substitute them in this equation that we made. Now let's just substitute them in this equation and we would get our answer 3x plus 1. This was our original equation. The value of a was minus 5 over 8. This will be our a. And then we have x plus 2. And then here we had bx plus c. So we would just substitute the values of b and c here. Our b was 5 over 8. Then x, and our c was 7 over 4. And then this. So that was it. That was how you solved irreducible quadratic factor.